Good evening friends, this is Professor Vishal, and in last session we started the most important concept, how to write down the empirical formula and how to write down the molecular formula. Okay, with the help of some examples we discussed that concept, and I think it was clear for you all. Okay, so after this we are going to discuss about the most next concept, that is stoichiometric chemical reactions or stoichiometry in a chemical reaction. Okay, let us understand this concept with the help of one example. Let us say when nitrogen reacts with hydrogen, correct it. When nitrogen react with hydrogen, I will get ammonia, or I can write here 2 times NH3, isn't it? So here this 3 or 2 represents coefficients, so these coefficients are known as stoichiometry coefficients. Okay, now if we see according to the law of conservation of mass, total mass of reactant equal to total mass of product. If you see this equation, you will come to know it is here total mass of reactant equal to total mass of product. Okay, now if for example if I will write this reaction like this, En2 when react with H2, I will get NH3. Is it okay? So this reaction is what we can say, it violating the law of conservation of mass, because total mass of product is not equal to total mass of reactant. Okay, and hence we have to use these stoichiometric coefficients here. Okay, so there are various relations through which, or we can see here, when 3 atoms of hydrogen, 3 moles of hydrogen react, we will get, or when 3 moles of hydrogen react with nitrogen, we will get 2 moles of ammonia. So in this way you can use this concept, or there are basically we are going to discuss basic relations of this stoichiometry in this session. So basically first one is a mass relation, then mole relation, then mass volume relation. So we are going to discuss these 3 relations, and with the help of that we are going to understand this concept. Okay, so here we are going to discuss with the first relation, that is known as mass relation. In case of mass relation, the most important thing is that first relation is mass relation. Okay, here what will happen in this relation, product is in mass and we will get reactant is in mass, actually we will get product is in mass. Okay, so we can write shortly here, reactant is given in mass, and will get product also in mass relationship. Okay, so for example let us say carbon will react with oxygen, I will get CO2. Okay, so now question is like this, if how much of CO2 is produced when, I will write here, how much of CO2 is produced when 24 gram of carbon is produced when 24 gram of carbon will react with oxygen, Okay, means question is like this, how much amount of CO2 is produced when this carbon quantity given as 24 gram react with oxygen, this quantity we have to find out. So here if we see this reactant is also in mass form, and we will get product in mass form. Okay, so for example, here most important thing is what, here mass of carbon is only given. Okay, so out of these two elements only mass of one element is given. Okay, so here if you see you will come to know here 12 gram of carbon, isn't it? And if you see 12 plus 32 means 44 gram of CO2. So I have to calculate, means what, therefore I can write here, if 12 gram of carbon gives me 44 gram of CO2, isn't it? 12 gram of carbon when reacted with oxygen, I will get 44 gram of CO2. Now what about 1 gram? When 1 gram of carbon reacts, how much amount of CO2 I will get? So simply I can write 1 into 44 by 12, or I can write here 44 by 12 gram. Means what, 1 gram of carbon when react with oxygen, I will get 44 divided by 12 amount of CO2. Okay, now here weight of carbon or mass of carbon is 24 gram. For 1 gram, so this much amount of CO2 is produced. Therefore I can write here, for 24 gram of carbon, how much amount of CO2 is produced. That is what we have to calculate as per this question. So 24 gram of CO2 means what, 44 divided by 12 into 24, isn't it? So 2, and it becomes 88, isn't it? So I can write as the part of answer, 88 gram means what, in short, how much amount of CO2 is produced when 24 gram of carbon will react with oxygen, or we can say when 24 gram of carbon will react with oxygen, I will get 88 gram of CO2. Okay, so that is what the mass relationship is. Okay, I hope you will understand it. Only the thing is that we have to given mass of only one element. Okay, not both elements are given. Either they will give you carbon, they have to and oxygen, mass of oxygen is not given. Okay, so here you will get mass of CO2 in this case. So reactant is in mass, we will get product also in mass. So this is what the mass relationship is. Okay, now we will discuss about the second relationship, that is mole relationship. Okay, you can take snapshot of this. So second type of relation is mole relationship. According to this relation, number of moles are given. In this type of relation, number of moles are given. For example, I will take one example. Let us say this same reaction we are going to discuss. Ammonia when react with hydrogen, we will get, nitrogen react with oxygen, hydrogen, we will get ammonia. Okay, so question is like this: how much ammonia is produced if 0.3 moles of hydrogen is reacted? Question is like this: how much ammonia is produced when 0.3 moles of hydrogen is reacted? When 0.3 moles of hydrogen is reacted. Okay, so we are going to understand this concept with the help of this problem. Okay, so what I will assume, or what I will consider most of the times, instead of writing down theory in it, just write down one example. So what will happen, it will give impact, it will create impact in your answer sheet, as well as it will easier to understand these concepts, isn't it? So unless and until you will understand it, you cannot write in your examination. Okay, so that is what I am thinking, and here I am producing, but here I am giving examples through which we are going to understand these mole relations. Okay, so in this case, question is like this: how much ammonia is produced when 0.3 moles of hydrogen is reacted? Okay, so if we see, initially if 3 moles of hydrogen here 3 moles of hydrogen gives me 2 moles of ammonia. Firstly calculate for 1 mole. Then 1 mole of hydrogen gives me how much amount of ammonia. So simply it is 1 into 2 divided by 3, or we can write 2 by 3. Means 1 mole of hydrogen will react with 1 mole of hydrogen gives me 2 by 3, 2/3 amount of moles of ammonia. Okay, now here question is like this: 0.3 moles of hydrogen will reacted with nitrogen gives how much amount of ammonia. For 1 mole it is 2 by 3. For 0.3 moles it is 2 by 3 into 0.3, so it becomes 0.1, or we can say 0.2 is the answer of this question. So I can write here 0.2 moles of ammonia, or we can say 0.2 amount of ammonia, 0.2 moles of ammonia is produced when 0.3 moles of hydrogen is reacted. Okay. Means what we have to consider the given relation first. Here I writing down 3 moles of hydrogen gives me 2 moles of ammonia. Calculate for 1 mole, and 1 mole it is found to be 2 by 3, and according to question here we have to find out the for 0.3 moles of hydrogen how much amount of ammonia will get. So it just multiply this by 0.3. Okay, or again I will write it once so it will be more clear for you. So it becomes 2 by 3 into 0.3, so it gets cancelled. 0.1, 0.1 to 2 is 0.2. Okay, so in this way you can calculate number of moles are given here. 3 moles of hydrogen gives me 2 moles of ammonia. First I calculated for 1 mole. 1 mole of hydrogen gives me 2/3 amount of moles of ammonia. When 1 mole of hydrogen gives me 2/3 moles of ammonia, then 0.3 moles of hydrogen gives me how much of ammonia? So 2/3 by 0.3, so it becomes 0.2 moles. Okay, so in this way you can easily understand this concept, that is mole relationship. Okay, after this we are going to discuss about the third relationship, which will easily understand, through which we are going to easily understand the stoichiometry in a chemical reaction. Okay, so third example or third equation I am giving you, third relation what we can say is mass volume relationship. Third one is mass volume relationship. Mass volume relationship, product is in mass and we will get here reactant is in mass and we will get product also in mass, gas we can say. Reactant is in gas, reactant is in gas, and we will get product also in gas format. Okay, so this is what the relationship. Again we are going to discuss one example here. So let us say 2KClO3 decomposes into 2KCl plus 3 times O2. Okay, so in this example if we see, question is like this: what volume of oxygen is produced? I am writing here question, what volume of oxygen is produced, what volume of oxygen is produced of 0.5 moles of KClO3. If 0.5 moles of KClO3 decomposes. Okay, I will again repeat the question. What volume of oxygen is produced if 0.5 moles of KClO3 decomposes, or we can say react? Okay, here if you see, 2 moles gives me 2 moles of KClO3 gives me 3 moles of oxygen, isn't it? 2 moles of KClO3 decomposes, it will use 3 moles of oxygen. This is theory, it is given in question. Then I can find out, so here I can write 2 moles of KClO3 decomposes, it will get 3 moles of oxygen, isn't it? And as we all know, 1 mole of is equal to, in terms of liter, 1 mole equal to 22.4, isn't it? So it becomes, I can write here 3 into 22.4 liter, isn't it? So means what? 2 moles of KClO3 decomposes, I will get 3 into 22.4 liter of oxygen, or we can say of oxygen. Okay, if this 2 moles gives me 3 moles, or 3 into 22.4 liter of oxygen, then for 1 mole I can easily calculate. So 1 mole it is 3 into 22.4 divided by 2. Okay, so it becomes 11.2, and 3 2s are 6, 3 1s are 3, 3 1s are 3. So it becomes 33.6. Means what? 1 mole of KClO3 decomposes, it gives me 33.6 liter of oxygen, isn't it? Then in your question, what they will ask? 0.5 moles. Means what? If 1 mole gives me 33.6 liter of oxygen, I have to find out for 0.5 moles how much amount of oxygen in liter I will get. Okay, means what? For 0.5 moles equal to this 33.6 into 0.5. Okay, it becomes, or I will calculate it, 5 6 are 33 is remaining, 5 is 15, 18 is there, 5 3 is 18. Okay, so I can say 18 point, 5 6 are 30, 15, 18, yes, 18.80 liter. Isn't it simple? Means what? In short, initially what I will assume, in this mass volume relationship, reactant is in mass and I will get product in as well also is in mass. Okay, so here I am giving one example, that is question is like this: what volume of oxygen is produced if 0.5 moles of KClO3 decomposes? The reaction is given, 2 times KClO3 decomposes into 2 times KCl and 3 times oxygen. So based on this reaction I wrote here 2 moles of KClO3 decomposes, it gives me 3 moles of oxygen. Okay, now why I am relating with oxygen? Because question is related with this term. Okay, what is the volume of oxygen? So I am discussing about the oxygen. Means 2 moles of KClO3 decomposes, it gives 3 moles of oxygen. Okay, so I am just converting this 3 moles into liter, so 3 into 22.4, so this is according to Avogadro's number, isn't it? So it becomes 3 into 22.4 liter for 1 mole. And in your question for 5 moles we have to find out the, when 0.5 moles decomposes, 0.5 moles of 2 KClO3 decomposes, it will gives me 18.80 liter of oxygen. Or simply we can here we can see, you will easily understood this concept again with the help of simple relationship. Means see, if 2 KClO3 gives me 33.6, isn't it? So 0.4 gives me 33.6 divided by 1/4, because this is 1/4. So if we calculate it, you will get the same answer. Check it once, isn't it? So you will get the same answer. Either you can use this method or this method, no issue. So in this way we have seen the stoichiometry in a chemical reaction. So basically we discussed about 3 relations. First one is mass-mass relation, in which product is in mass, we will get reactant is in mass. Then we have seen second mole-mole relation. Here number of moles are given, isn't it? And we have to find out the number of moles in reactant and product side. And third case, mass volume relationship, this volume, so this relationship, here reactant is in gas, you will get product also is in gas. So We will take one example here. In all cases I am discussing in I am trying to discuss all three cases with the help of practical example. Okay, so first calculate for 1 mole values, then respective values can be calculated in an easy way, isn't it? So, or we can say value of one product is known to us, we can calculate the value of nth product simply by multiplying. So same rule I applied here and I will get the answer as a 88.8 liter. Okay, so after this what we are going to discuss, if we see these three methods, you will come to know in your question either they will give you one element out of two. Here if you see what volume of oxygen is produced when 5 moles of KCl3 decomposes, means what KClO3 here they didn't give us volume of KCl or moles of KCl and O2 both, either they will give you one element or another element. Okay, now what will happen if the number of moles of reactant 1 and reactant 2 is also given, then here we have to use another important concept that is known as limiting reagent and excess reagent. Okay, so now we are going to discuss about these two concepts, limiting reagent and excess reagent. Okay, so we will discuss about this limiting and actually this is limiting reagent and excess reagent. I will give you simple example to understand these two concepts, then we are going to discuss more about this. So for example, I am burning a paper. Okay, I am having bunch of papers and I am burning one by one. So during this burning, carbon dioxide gets out from that particular process, isn't it? So how much time should I burn? Unless and until my paper gets finished. Okay, means once paper gets finished, that burning process gets stopped. So paper in this case or in this example what I told you, so is nothing but the limiting reagent, means they are about to end. Okay, now second concept, for burning we need oxygen. Okay, though paper ends, oxygen is continue for burning process. Oxygen is there in order to complete this burning process. So oxygen is continuous, so oxygen is nothing but the excess reagent. Okay, so simple example, burning of paper, you can understand this concept. Means what limiting reagent is, what simply when we discuss, if the compound which finished after reaction, means once reaction ends, your compound gets finished, your compound also ends, so that particular agent is known as limiting reagent. Okay, and if your reaction ends till the product is left behind, so that is known as excess reagent. Okay, so we will discuss about this. So how we are going to define the limiting reagent? First one is limiting reagent. Okay, second one is excess reagent. So firstly we will see the definition of limiting, then we will discuss about this excess reagent. Okay, so according to definition, it is the reactant which is completely consumed. Actually it is the reactant which gets completely consumed during reaction. Okay, so means what, if I am taking one of the reactant and during this reaction it gets completely consumed, no residual part is remaining, so that particular reagent is known as limiting reagent. Okay, so And what about excess reagent? So it is the reactant which led behind after the reaction, or we can directly write reagent which left behind during reaction, or simply limiting reagent is what? The reagent which gets completely consumed, so that is limiting reagent, and some reagent which is left behind, isn't it? So that is known as excess reagent. So these two terms are important. So we will see, for example, I will give you one example here again. So same example, ammonia will nitrogen will react with ammonia, hydrogen we will get ammonia. Okay, nitrogen will react with hydrogen, I will get ammonia. Okay, so in this example, if we see, so if we see in this example, question is given again. Question is like this: how much of amount of ammonia is produced? How much amount of ammonia is produced if 50 gram of nitrogen, if 50 gram of nitrogen react with 10 gram of hydrogen. Okay, so we have to find out the quantity of ammonia produced in this reaction. If this nitrogen is 50 gram, this is gram, okay, and if hydrogen is 10 gram, we have to find out how much amount of ammonia. So if we see this question and if we compare this question with previous questions, that is stoichiometry in chemical reaction, we will come to know in that case either out of these two reactants, either mass of one reactant is given or other reactant is given. So in that case, there was never two masses of two reactants are given. Okay, so but in this case, mass of first reactant, mass of second reactant is given. So that is how we are going to differentiate these two concepts. Okay, or these two numericals we can say. So here if you see, you will come to know in this question we have to solve this question in 3 steps. Okay, so let us discuss first step, calculate number of moles. First step is calculate number of moles. Okay, so let us say I am going to calculate the moles of nitrogen. For first case it is nitrogen. Number of moles of nitrogen, simple formula, weight divided by molecular mass, isn't it? So weight is given as 50 gram for nitrogen, so it is 50. Molecular mass, so it is 2 atoms are there, so it becomes 2 into 14, so it becomes 50 divided by 28, or if I will simplify it, I will get as a 1.7 moles, isn't it? Means what? 1.7 moles nitrogen is there. A number of moles of nitrogen in this compound is 1.7 moles, and for oxygen, sorry, for hydrogen, number of moles of hydrogen. So again same formula, weight upon molecular mass. Weight is already given 10 and molecular mass is 2, so I can write 5 moles. Okay, so if we see, number of moles for nitrogen is found to be 1.7, and for number of moles of hydrogen it is found to be 5. Okay, so if we see, this is your first step, calculate the number of moles. Then second step, according to the equation, we can say that step 2, I will rub it. If you understand it, I can rub it. Okay, so this reaction is and question is given to you. This understanding the concept of limiting and excess reagent. Okay, So if we see here, question is like this: how much amount of ammonia is produced if 50 gram of nitrogen and react with 10 gram of H2? So according to this weight, we have calculated in first. So in first step, we have calculated the number of moles. I write here number of moles for nitrogen is found to be 1.7, and for hydrogen it is 5. Okay, so we need it for second step. So in second step, we have to consider equation. So according to equation, if we see this 1 mole of nitrogen when react with 3 moles of hydrogen, isn't it? So I will get 2 moles of ammonia. So I can say that for 1.7 moles of nitrogen, according to this, how much ammonia, how much amount of hydrogen should I know, so that I will get same amount of ammonia. Okay, so here I will do 1.7 into 3. So I can say that this much amount of, I can write here 1.7 into 3 equal to 5.1 moles. Means what? 1.7 moles of nitrogen when react with 5.1 moles of hydrogen, I will get 2 moles of ammonia. Okay, so here actually if we see, total number of moles available for hydrogen is only 5, but required it is 5.1, isn't it? So means what? We can say that the number of moles are less, or we can say according to the definition of limiting reagent, the reagent which are already consumed, which gets completely consumed. So here they gets completely consumed. Hence we can say that therefore hydrogen is limiting reagent, isn't it? The reagent which gets completely consumed, or reactant which gets completely consumed, is called limiting reagent. So 5.1 required is less than 5, so we can say that it is limiting reagent. Now we will see third step. Again, if we see according to equation, now we discussed in first step about the nitrogen. Now we are going to discuss in third step. In second step we discuss about nitrogen. Now in third step we are discussing about hydrogen. Okay, so if 3 moles of hydrogen react, it will give 2 moles of ammonia. For 1 mole of H2, it will use 2/3 moles of ammonia, or I can write NH3, isn't it? But how many moles, how much amount of moles are available in case of hydrogen? 5. So for 5 moles, I can say 2/3 into 5. 2/3 into 5, which is equal to 10/3, and it becomes 3.33 moles. Okay, it means what? When 5 moles of hydrogen reacted with nitrogen, I will get 3.3 moles of ammonia. Okay, so in this way you can easily calculate what is the limiting value of limiting reagent and excess reagent. So I hope it will understand to you. So again I will quickly revise. So in this, understanding this question and giving this reaction, and first step I calculated the number of moles, and it is found to be for nitrogen it is 1.7 moles, and for hydrogen it is 5 moles. Then second step I will consider nitrogen. So I calculated how much amount of hydrogen is required for getting 2 moles of nitrogen. So it is found to be 5.1 moles, which is less than 5. So this hydrogen becomes limiting reagent. Okay, now after this we are going to consider hydrogen. So in third equation, according to equation in third step, 3 moles of hydrogen gives me 2 moles of ammonia. Therefore I am calculating 1 moles of hydrogen needs how much amount of ammonia. So it becomes 2/3 of moles of ammonia. If 2/3 of ammonia I will get from 1 mole of hydrogen, then for total number of moles of hydrogen available is 5. So for 5 moles of ammonia, I will get 5 into 2/3, that is 10/3 equal to 3.33 moles of ammonia. Okay, so in this way we have discussed this concept, limiting and excess reagent. So now after this we are at the end of this chapter. Only one, I think 1 or 2 sub bits are remaining, out of which concentration of solution is the most important. We are going to discuss this in next session. Okay.